Hello, I'm Roman. Welcome back to the series of the videos Let's Learn Go language, where we study the tour of the Go and we actually check in the official first tour of the Go and trying to learn the programming language. I used to use it in the neural networks from scratch series, but I didn't check the whole tour of the Go, and I think this is the good time for me to properly went through it and learn all of the must-have things that I described here. So in the previous and the first video, we started from the basics. We checked all of the things, and currently we are at exercise loops and functions. And what we need to do, we need to implement Newton's method to calculate square root. And there are a couple of things I need to do here. First, we need to define the descent starting from 1. And the second one would be, what is the second one? I will need to have, where is it? I mean, I will need to do a comparison and understand what's called. Come on, the precision. Yeah, we need to define some precision value at which we're going to stop. So what I'm going to do, I'm going to define two constant values. How would name it? Well, the first one would be like delta, which would be lot 64, and I need something small, something like this. And then I need to have the z default value, which will be the int, and it should be 1. Oh, no, it's actually, well, okay, that's mark it as a float too. So what we need to do, we need to calculate the square root and return the float value. So, and then let's see, okay, but no, let's use something interesting. Okay, so we need to so I need to define z value that we're going to return. What else? Implement the square root per descent, start with a guess of that one, no matter what the input. To begin with, repeat the calculation 10 times and preach that along the way. See how close you get to the answer of the verb. I mean, okay, I need a way to calculate this one. So that should be something like, okay. That will be something like the step, because we'll go over and over, and we'll take z and x as a parameter, so that will be float 64 and return float 64. It's too hot in here. I mean, it's late evening. I'm recording this, and it's like 33 degrees still. And there is no AC in this apartment, so it's pretty hard. Okay, what I'm returning? I'm going to return z multiplied by z minus x and divided by 2 multiplied by that, right? So then what we need to do? I think there is 4, and I actually will try to use the new information from the for loops. So so there is a value I call the step, which is and x. Then I need to check if this is, I still need to do the calculations, and can I leave the last one blank? Will it work? Okay. I need to decrease, right, for this value. Still one. Print len b. Okay, let's take a look. Don't be this and this. Oh, see how close you get to the answer. But I guess it should be like this, right? Math. Okay, yeah. I need to reassign it once again. Yeah, okay, maybe it's not a... Maybe it's not a good... Yeah. It's not the best usage of this... of the 4 P's declared but not used. Are you sure? Yes. Sure. Okay. Yeah, it's pretty close. Okay. Okay, so maybe... So I guess it should be this one and this one, right? Will it be the same? Yes. So it's kind of while true, you know, when you first do the action and then you validate the condition. Okay, let's move on. Switch. A switch statement is a short way to write a sequence of if-else statements. It runs the first case whose value is equal to the condition expression. Go switches is like the one in C, C++, Java, JavaScript, and PHP, except that Go only runs the select case, not all the cases that follow. In effect, the break statement that is needed at the end of each case in those languages is provided automatically in Go. Yeah, I mean, I really don't understand what was... No, okay, maybe. I mean, for example, I think, yeah, in Swift you can write case and you can define several cases with a comma, and then you can write an action. And I think this is more readable, but you know, having stuff like this, and then you do this stuff, and you need to break it. I mean, this is so good way to shoot yourself in the leg, especially if you have, you know, too many constants defined and you need to process them. But I mean, okay, I think this automatic break is much simpler to debug, at least from my perspective. Another important difference is that the Go's switch cases need not be constant, and the value involved need not be integer. Okay. Go runs on Linux, Darwin, FreeBSD default. Okay. Switch cases evaluate cases from the top to bottom, stopping when a case succeeded. Does not call f if I equals to 0. Note. Time in the Go playground always appears to start at this time. Okay. What happened? This is a time and date of Go length's birthday. Okay. A value involves significance left unexercised for the reader. Okay, we have the time, the weekday. If there is a Saturday, today, tomorrow, in 2 days, too far away. Okay. too far away. Yeah. Which without a condition the same as switch true. This construct can be a clean way to write long if then else chain. What? Switch without a condition is the same as switch true. Oh, okay. So basically there is no value provided to the switch. We just write in the cases with the conditions. Oh, I think that's what it was mentioned, that the value in the case is not required to be a const value, like const you here provide. There's actually can compute. So it's basically an if statement. Yeah, I think that's pretty good evening. Good evening. Somebody watching me? Okay. The first statement defers the execution of a function until the surrounding function returns. The deferred calls arguments are evaluated immediately, but the function call is not executed until the surrounding function returns. Basically, there is a return, like return. Probably it will shout at me. No. So there is a return, and then it goes into the deferred. Deferred function calls are pushed onto the stack when the function returns. These deferred calls are executed in last in, first out order, so it's exactly the stack. So yeah, we can see that it's calls defer with the printf. So we will see numbers going starting from 9 until the 0, right? Yes. We're going to the next lesson. Pointers. Oh, pointer and pointer. Go has pointers. I think this is the juicy stuff starts. Pointers, new slices. Yeah, I think this is the interesting part. Methods, interfaces, generics. Okay. The type star. I think this is called star, right? The pointer to value t. Its 0 value is nil. So we have a variable p, which is a pointer to the integer. The AND operator generates a pointer to its operand. So p is assigned a pointer to the I, right? The star operator denotes the pointer's underlying value, and then we can kind of unwrap what is lying under this pointer. Set I through the pointer. Yeah, this is known as a difference in indirecting. Unlike C, Go has no pointer arithmetic. Thank you. Pointer arithmetic is a very strong tool, but I mean, once you start to use it, you can make so many different bugs that is very, very, very hard to debug. Okay, let's take a look at the example. So we have two integer values, I and j. Here there is a p, which is a pointer to the I value, right? So then we use the star to kind of unwrap what lies under the pointer value, which should be a value 42, because p is the pointer to the I. Then we use the pointer to set the value, and it should change the I, right? Correct. Okay, then we reassign p point to the j, so to this number. Then, yeah, what we're doing, we setting a value into the bucket which is this pointer points, which is this value, Then we take this value by the pointer, not from the j, but by the pointer, and we divide it by 37. And we set the new, and then we can read this value. Okay, so there is the same with string. So we have the pointer to the string, and then we change the value under the pointer. I hope I articulate properly all of the terms regarding the pointer. And then we take a look at the value under the pointer and we check that we actually changed the string. So yeah. Start with the collection of the fields. Thank you. Struct fields are accessed using a dot. Nice. Struct fields can be accessed through a struct pointer. Struct fields can be accessed through a struct pointer. Okay, so I will start reflect. I think there is a better way to do this, but I will reflect type of E, and that should be start vertex, right? Yeah, start vertex. To access the field X of a struct when we have the struct pointer P, we could write where the notation is current sum, so the language permits us instead to write p.text without an explicit difference. But I can write this, right? Start literal denotes a newly allocated struct value by listening the values of its fields. You can list just a subset of fields by using the name and the order of the name fields is relevant. The special prefix and returns a pointer to the struct value. Oh, okay. Is implicit by default. Okay. The type, number, and t is an array of n values of type t. The expression declares a variable a as an array of 10 integers. An array's length is a part of its type, so arrays cannot be resized. This seems limiting, but don't worry, Go provides a convenient way of working with arrays. Okay. Okay, so we have the hello world, the array, and then we have prime numbers. Okay. So far, so good. An array has a fixed size. A slice, on the other hand, is a dynamically sized, flexible view into the elements of an array. In practice, slices are much more common than arrays. The type just brackets t is a slice with element of type t. A slice formed by specifying two indexes, a low and high bound, separated by the column. Low and high. Okay. This is the slice of this array. Slice from 1 to 4. Why it has only 3 values? This selects a half open range. Half open, okay, but excludes the last one. All expression creates a slice which includes elements 1 through 3 of A. Okay, so it's basically if you write in this notation like this. Slices are like reference to arrays. A slice doesn't store any data, it just describes a section of the underlying array. Changing the elements of a slice modifies the corresponding element of its underlying array. Other slices that share the same underlying data will see those changes. Okay, other slices that share the same underlying array will... Okay, so let's take a look. So we have an array. So, okay, I should use the correct terminology. I guess the main I think the thing to understand here with the naming, I guess, is that array always has fixed size, but the slice is dynamically sized, which references to the array. And I guess when you increase slices size, I have a feeling that it creates a new array under the hood, kind of copies the data. And because, I mean, in other languages, there is a just fixed sized arrays and dynamically allocated, dynamically sized arrays, and they both called as arrays. And for example, in Swift, you could have the fixed sized array, the dynamically sized array, and you could have the slice. There is a special API, like similar to, not similar, but I mean, there is a kind of similar idea that you could have this slice that references the underlying, like the original array, and it can work with the dynamically sized array. So I guess the main difference here is that there is always the fixed sized array. Okay, so we have the names, then we create two slices for these values and for these values, right? And if we change the B0, which is the first element in this slice, which reference to the pole. So the pole should be 3 axes right now. Names, AP, this is the slices, yeah. Okay. Correct, right. Nice. Slice literals. Slice literal is like an array literal without the lens. This is an array literal, and this creates the same array as above, then builds a slice and reference. Okay, so I was right. Basically, it creates a slice. Well, it creates an array, and then it creates a slice that references this array, and we can work. Okay. So we have some values, then we have two slices with two arrays under the hood. Then we have struct, and again we have the slice. Okay, so it's just an example of the slices, right? Okay. Slice defaults. Okay, where I am, I want to understand slice defaults. Okay, I'm here. There is exercise and slices, and maybe. Okay, let's see. When slicing, you may omit the high or low bounds to use their default values instead. What do I mean? When slicing, you may omit the high and low bounds to use their defaults instead. The default is 0 for the low bound, and the length of the slice is the high bound. So for the array, these slices expressed are equivalent. Okay. Okay. 2, 6. But I guess if it will be 6, and then it will be, that should be the same. Yes. Slice length and capacity. Okay, this I had the correct prediction. Like a neural network, I had the correct prediction. The length of a slice is a number of the elements it contains. The capacity of the slice is the number of the elements in the underlying array counted from the first element in the slice. The length and capacity of slice S can be obtained using the expression len and cap, which length and capacity. You can extend a slice length by reslicing it, provided it has sufficient capacity. Try changing one of the slice operation to an example program to extend it beyond its capacity and see what happens. crash will happen. Right. Let's do this. Boom. Slide bound out of the range with a capacity of 6. Right. Wait. So I have this slice. Length 6 and capacity 6. Then I have slice, it's given. Okay, but the underlying capacity is still 6. Then we have 4. Oh, we're actually extending it. Okay. Oh, because we shifted it from the 2. So it's 0, 1. So from this one, the capacity is 4 here. Because it kind of starts from here until the end of the actual array. Okay. Nil slices. The zero value of a slice is nil. Wait, the zero value of the slice is nil. A nil slice has a length and capacity of 0 and has no underlying. Okay, so this is the default value of the slice is nil. Okay. Slice can be created with built-in make function. This is how you create dynamically sized arrays. Yeah, this is what I've used. The make function allocates a zeroed array and returns a slice that refers zeroed. So yeah, it returns an array with number, well, with elements equal to 0. To specify capacity and pass a third argument to make. Oh, so I actually can. What is 0? Wait, dash make this one. The make built-in function allocates initialized an object of type slice map with chain. Like new, the first argument is a type, not a value. Unlike new, makes return time. No. For example, make int 010 allocates an underlying array of size 10 and returns a slice of length 0 and okay. Okay, so we actually can extend something. Okay. Slices of slices. Ooh, slices can contain any type, including other slices. Play the tic-tac-toe boards. Okay. It is common to append a new element to a slice, and so Go provides a built-in append function. The documentation of the built-in package describes append. And we can do this, not the inversion, no, this one. Built-in append function appends element to end of the slice. If it has sufficient capacity, the destination is resliced to accommodate the new element. If it does not, a new underlying array will be allocated. I told you. This is what I told you. Okay. Append returns the updated slice. It is therefore necessary to store the result of append, often in the variable holding. Okay. But can I? Okay, the elements, but I have no control, on the size of the relocation. The first parameter is a slice of type D, and the rest are T values to append to the slice. The resulting value append is a slice containing all the elements of the original slice plus the provided values. If the backing array of the S is too small to fit all the given values, a bigger array will be allocated. The return slice will point to the newly allocated array. But the only question I have, I'm curious, how it will determine the size of the underlying array, just like to fit all of the items, or will it kind of expand it a little bit, or do I have control on this? Because, for example, I know that I will be appending to my... Oh, okay, I can append them. Okay, forget. Range. The range form of the for loop iterates over a slice or a map. When ranging over the slice, two values are returned for each iteration. The first one is the index, and the second one the copy of the element of that index. So it's actually a copy, right? Can I change the example? And so it will be copy, right? I cannot use pow. Cannot use pow variable of type as a string value in the argument. Okay, so it's really a copy. So if I change the v, I do not change this one, but if I want to change the value of the slide that I'm iterating right now, I need to do this, right? Yes, okay. Right, you can skip the index or value by using the underscore. If you only want to use index, you can emit the second variable. Okay. Exercise. Okay. Implement pick. It should return a slice of length dy. Each element of each. Okay. I will stop. I think this is the good time to stop. I will sleep with all of the new information because need to process and actually learn a couple of the new things, and then we will start tomorrow with the exercise on the slices, and then we'll go over the maps and function closures. I mean, this is maps. Yeah, it should be. Probably I will fit 2 exercises into 1 video tomorrow. This I will try. Yeah, interesting functions, blah, blah, blah. Okay. Yeah, that's all for today. Thank you for watching, and I see you tomorrow. Bye-bye.